So, welcome back. We were looking into the tower, transmission tower, where the linemen prefer working with lightweight polymer insulator instead of the ceramic or glass type of insulators, which are of more weight than the ceramic. Just for comparison purpose, you can see the two insulator strings, a polymer insulator string and a ceramic or a porcelain insulator string. In case of 400 kV, typically for a 400 kV system, the insulators numbers will be somewhere around 23 to 25 disc insulator each side. So, 23 into 2 is 46 insulators, 46 insulator, each insulator weighs somewhere around 10 to 12 kgs. So, around 500 kilos plus the hardware, it comes to around 1 ton in case of a ceramic insulator, whereas for a polymer insulator, the each will be a few 10 to 12 kg. So, totally the weight reduction will be more than 60 to 70% here. That is where the technicians or the linemen prefer to work with lightweight polymer strings, which are more aesthetic and which have less weight, and it is much comfortable for the people to work in the high voltage and extra high voltage transmission systems. So, we were looking about various types of insulators which are being used for the high voltage and EHV, UHV transmission. We will look one by one into the reliability and the importance of the testing for the ceramic, glass and the polymer based insulators. So, what is reliability and testing is a very important aspect which for the safe operation, the reliability becomes an important factor for the safe operation of any electrical equipment, which depends on the integrity of its insulation for which it is designed. So, the high voltage test basically is an attempt to deliberately apply a slightly higher voltage to the equipment than its normal working voltage for a specific period of time. This is how the high voltage tests are being conducted in the industries, that is the manufacturing units, as well as the research laboratories or the certification laboratories. So, intentionally slightly higher operating voltage than the equipment sees in the field is applied for a specific period of time and its integrity is verified. So, not also helps to discover if the insulation withstands for a period or breaks down under that voltage. So, this gives an idea where how reliable is the product which can be used in the field. So, the purpose of the high voltage test is mainly to demonstrate that any apparatus has to be met with the guaranteed specification for the insulation or the dielectric strength which it is designed. So, these high voltage tests which are being conducted also provide a check or verification on the design which is to be put up in the field, a determination of strength of the materials which are being used as an insulating media, and also provide a guide to the development of better equipment in case the insulation which has been used has to be upgraded or a further improvmental aspect could be carried out. So, this helps the reliability, helps to achieve better insulation for the equipments to be used in the transmission or the distribution systems. So, when we were looking about the testing aspects, what is the basic philosophy which pertains to the high voltage testing? Why the testing is essential for the high voltage equipment? So, high voltage test or the verification which is being done in the laboratories or at the industry is expected to provide a reasonable field procedure, that is in the laboratory when they are conducting the tests or experiments on a particular product, it has to be reasonably simulate the field conditions, which should involve a reasonable time, in the sense you cannot try to simulate in the lab for a large number of years or a long period of time. So, the time should also be reasonable, and also it should give a reasonable assurance to the manufacturers or the utilities that the apparatus, whatever the testing is being conducted, will give some expected satisfactory performance and gives an idea of its field performance. So, this is an expected from the reliability or a laboratory testing which is being carried out, and most of the laboratory testing or the experimental procedure involves with the standard procedures laid down as per the international standards, and the procedures are being described in several standards pertaining to the equipment. So, these tests may simulate one or both of the following. The tests can simulate worst case situations in the field. Sometimes the laboratory experimentation, the methods which are being followed could be much more rigorous in comparison to the field conditions. The second point of importance is these tests are imaginary, but sensibly severe conditions that when it is being conducted could ensure long life in service. So, these are the two important conditions when we simulate the testings in the laboratory or at the industry for the any high voltage components. Also, the quality of the laboratory testing or the industrial testing or the factory testing is normally assessed by the importance of these three factors. The first being the repeatability. Repeatability is ability of a test to produce same or a reasonable same results every time in the lab. So, this indicates that when the particular test is being conducted at a different instant of time, at a different period of time, the same test, the results which are produced should be reasonably very near to the values which have been obtained earlier. So, this shows the repeatability nature of the laboratory of the equipment which is being used for the testing the equipments. Second is the reproducibility. Reproducibility is an ability to produce same results every time in any lab. The first one, repeatability, refers to a single laboratory, whereas the reproducibility is a method where reasonable results of a particular test could be obtained any time the equipment is being tested in any lab with a minor variation as per the international standards. So, the third being the representativity. Representativity is an ability of a laboratory test to duplicate service or field condition. This is very important, very few places in the world have the facility. The representativity is a testing procedure where the actual simulation of the lab or a field conditions is done. So, the laboratory which should be equipped for testing these equipments should be able to represent similar to the field conditions. So, such labs across the globe are very few where the representativity or representativity tests could be carried out for the equipments. So, what are the failures of electrical apparatus or any high voltage apparatus which are normally observed in the field? So, it is known almost and always the failures occur because of the electrical insulation system. Some of the parameters which could influence the performance or the life of the insulation are the following. The number one being the electrical stresses. So, electrical stresses, the equipment or the insulation of the equipment could lose its performance over a period of time. This is due to the normal working stress continuously over a period of time or due to the over voltages. So, the insulation which is in continuous stress and also takes the over voltages may lose its properties over a period of time because of continuous electrical stress. The second being the temperature. So, the temperature, again the insulation has to withstand along with the electrical stress the normal working conditions. The temperature due to overload conditions, particularly in case of transformers, the hot spots which are developed because of the multi insulation like the oil, the paper and the electrical stress So, in such case, because of overload conditions, the normal the temperature surrounding the insulation will be higher. So, here again the temperature plays a role in the life of a insulating material or a insulation system. Then ambient conditions, other than temperature, very important is the moisture or humidity. We have looked into how the moisture could influence the life of the insulating material. So, the moisture, humidity, pollution or a contamination, the dust particles, chemical vapors, etc., apart from solar and other UV radiations also have an influence on the performance of the insulating system electrically. So, this effect of moisture, humidity and other things will be discussed in the testing aspects for both the polymer as well as the ceramic insulators for the tests which like the multi-stress in case of the polymer insulators have to undergo all these type of stresses. So, apart from electrical ambient conditions, the mechanical stresses, particularly the mechanical stresses which the insulation or a component or insulator sees during transportation, the storage of raw materials, during manufacturing process, during quality control testings movements at various locations in the industry, during packaging, loading, transportation. See, all this could lead to a mechanical stress on the product where the insulation could be affected. Apart from this, during normal loading and unloading of the material, movement to the final location and commissioning. So, several of these factors influence the insulation apart from the electromechanical forces which could be due to the short circuit during the service. Now, coming back to the classification of the tests which are conducted for the insulations, the same could be verified as mentioned in the laboratories or the industries. The International Electrotechnical Commission and IEEE standards, apart from other standard organizations, have classified various tests or various experimental procedures to be adopted to certify or to check, verify the equipments or the components could be used in the field. So, various classification of the tests are classified as the type tests which are normally conducted in the research laboratories or the third party testing laboratories, the certification laboratories, the sample or the acceptance tests. The third is a routine tests which are normally conducted on each and every component in the industry, and some other special tests as the voltage levels go up above the EHV and UHV. Apart from type, sample, routine tests, few special tests have also been incorporated, introduced to verify the design of the insulation when the usage of for ultra high voltage or extra high voltage transmission system. So, the type tests which are normally performed is to verify the main design characteristics on a particularly small number of samples and normally once for a new design. So, example, in case of insulators, if the design remains same for a particular voltage level, for a particular creepage distance, the insulators manufactured, a small number of samples from that particular lot are type tested in the type testing institutes or the laboratories. Unless the design change, the test need not be repeated. So, these type tests consist of electromechanical failing load test, mechanical failing load test, thermal mechanical test where both the thermal and mechanical loads are tested for the insulator string, dry lightning impulse or dry lightning surge test which specified for a particular voltage level, then wet power frequency withstand test. Wet power frequency is simulation of artificial rain to the insulator strings and verify whether they could withstand for a particular duration for a particular voltage levels. Then followed by that is the visible discharge test or the corona test. So, visible discharge test or the corona test, which are normally conducted for the extra high voltage and ultra high voltage, gives an indication where the corona, which is visible from the hardware or the insulator accessories, has to be contained, where the discharges should not, particularly for polymer insulator, should not bring down the insulation level. Apart from this, the type test also contains the verifications of the actual dimensions of the equipment which has been manufactured. So, the sample test or the acceptance test are basically to verify the characteristics of insulators that could vary with manufacturing process. So, here normally the insulators which are manufactured are taken at a random from a lot of existing type. So, here again the sample test consists of puncture withstand test for a particular voltage level, the insulator should not puncture. The porosity test to check the material properties, no porous, there is no porosity in the insulation. The galvanizing test, proper galvanizing is being carried out for the metallic pin and the cap. The thermal shock test, this thermal shock test also will help whether the insulator can take this type of loads in the field. The temperature cycle test, again the temperature, higher the temperature or operating more than the operating in the field is applied for a known period of time, and the verification of the insulator is being done whether it could withstand over a specified period. Then again verification of various locking systems, cap and pin, metallic hardware. So, verification of dimensions etc., fall under this acceptance or a sample test category. The third being the routine test. Normally, as mentioned earlier, routine tests are performed on each and every insulator sample. So, in the factory these are performed mainly to eliminate the defective insulators during manufacture process and prior to the crating and shipment. So, in case if these routine tests are not carried on each and every sample, there are likely that there may be some insulators with a defective, which could again see the failure in the field. So, the routine test has to be performed on each and every samples. The tests include mechanical tests, some electrical tests, visual inspection etc. So, these are the various three categories of tests which are specified as the important verification procedural methods for the insulator string. Apart from the type, sample, acceptance or routine tests, some other special tests have also been adopted, particularly in the recent time, as to verify the service performance for long period of time. Here the demand for power, with the increase in demand for power, the transmission voltages have correspondingly increased over the period. So, presently we have reached ultra high voltages from low from 11 kV voltage levels. So, subsequently 132 kV, 220, 400, 765 or 800. So, again it is planned to increase the voltage to 1200 kV AC system. So, this increases the cost of the insulator string, tower and many of these things. So, the present day design mainly demands for the factor of safety, which is very important. Minimization of the risk of failures has to be kept in mind, and the improved quality and reliability in service is a primary or an important concern at higher voltages or extra high voltage or ultra high voltage. So, to achieve the service reliability, the manufacturers or utilities normally conduct the following tests, which are categorized as the special tests, particularly for EHV or ultra high voltage levels. The tests include long term reliability tests, accelerated aging test. Again, accelerated aging, this particular test is being carried out over a long period of time. It depends 1000 of hours to 5000 hours, where the acceleration factors like the voltage, temperature, etc. are increased to an level depending upon the voltage and the string which is going to operate, and the tests are conducted for a long duration of time. Then the contamination or a pollution test, this is again a very important at extra high voltage and ultra high voltage. Power arc particularly very important for the EHV and UHV voltage levels. Radio interference voltage, the corona test, again the discharges which are emitting from the hardware, the corona control rings or insulator accessories are very important, and these have to be seen. The discharges should not have a higher magnitude, and specified limits have to be followed as per international norms. Next being the voltage distribution in the string of for a 400 or 800 kV, the number of insulators go on increasing. In case of 400, as mentioned, we have 23 to 25 disc insulators. In case of 765, we have anywhere between 35 to 40 disc insulators. So, the voltage distribution, that is from the line end to the ground end, becomes essential. It has to be maintained, else if without proper voltage distribution, the stress which the insulator which is near to the line end sees very high voltage across or very high stress across that, and over a period of time the insulator could shatter and could lose its insulating properties. That is the reason a proper voltage distribution has to be maintained for the insulator string with proper corona control rings, arcing horns, or a suitable hardware which is being employed for the string. So, next is the switching surge, which is very important at EHV levels. So, switching impulses for a voltage levels operating above 400 kV cause the insulation to break down early. So, switching surge tests are normally carried out for all the equipments for the specified levels. Then power frequency over voltages, because in the transmission during the normal working voltage, that is the power frequency working voltage, there could be some disturbance in the transmission network over voltages for a few cycles could be witnessed where the insulation has to withstand. So, the power frequency withstand voltages are normally carried out for both the dry as well as wet conditions, apart from some of the fatigued mechanical tests. So, all these come under the special test category, and these are normally conducted for the voltage levels above 400 kV. So, as the voltage level at EHV and UHV has to be maintained for the transmission without the insulation being degraded in service. So, this is one of the arrangement for 765 or 800 kV transmission system in the laboratory. In a typical laboratory, the source is very important. The source should be able to deliver the required voltage. This is a 0501 million 50 kV cascade transformer, where the insulator string, there is a V configuration string is being erected. The testings like the voltage distribution across the insulators, entire insulator string, the radio interference voltage and the corona are being tested before the insulator string is actually mounted in the field. So, similar arrangements are normally carried out for various type tests or special tests in the laboratories before the insulator string is being energized in the field. The table gives some information about the insulation characteristics, particularly for suspension towers of various company or the countries which the voltage, higher voltage levels or ultra high voltage is being operated. You can see here hydrocubic 1 and 2 are the Canada, there the nominal voltages adopted are 735 kV. The minimum strike distance, the strike distance which we were discussing should be for 735 kV is 4.1 meters. The insulators could be a porcelain or a glass type. How many number of insulators in a 735 kV is the number of insulators at 33 in numbers. The mechanical rating or the mechanical rating of each disc is 110 or 160 kilonewton is the mechanical strength for disc. Then the column shows the ESDD, equivalent salt deposit density, when the transmission lines are running near the pollution zones. So, that particular pollution zones, what is the equivalent salt deposit density which is being used has also been categorized here. Then the final column gives the creepage in millimeter per kV adopted for the insulators. That is the 14 is the 14 mm per kV is the adopted creepage of the insulator. You can see various companies in the in different countries the voltage levels which are being adopted 735, 765 and the minimum strike distance, the what type of insulators are being used and how many number of insulators are being employed in a string, the mechanical rating, the pollution conditions and the creepage employed are being given here. So, this particular information which is adopted in the country by the Power Grid Corporation of India shows 765 kV insulator string where we have a minimum strike distance of 5.1 to 5.6 because of the wind prevailing in that particular belt and we use a porcelain or a glass insulator with insulators as I mentioned earlier 35 to 40 are the insulator discs which are connected in series and is being used in the country. The mechanical rating being 120 kilonewtons and 210 kilonewtons are presently being employed and 0.03 is the equivalent salt deposit density, that is the pollution zones which we are employing, and 16.9 is the mm per kV. This you can compare with the other we have a higher pollution areas, that is one of the reason we go in for higher creepage per kV levels. So, similarly Russia has employed for glass insulators and Japan has also employed a porcelain insulators for 1000 and 1150 kilovolts. This gives minimum maintenance experience of lines built in various countries across the globe.